Hello friends, in this video we are going to solve a problem on how to determine the analogous system of a mechanical system. And this analogous system we will derive it or determine it by first finding the mathematical model of the system, writing the nodal equations for it, and from those nodal equations we will determine the analogous system. So let us first, what is our problem? Let us see what is the problem. So this is a mechanical translational system, and it is having two mass elements M1 and M2, two dampers B1 and B2, and two springs K1 and K2. We have two displacement x1 and x2 and an external force F is applied on this system. So for this system we have to determine the analogous electrical network. Okay, so for this first we will draw the nodal diagram for this system. So let us draw it. We have two displacements x1 and x2, so there will be two nodes. Then we will draw the reference line. Okay, and we know that this B1 and K1, they are connected between the nodes x1 and x2, and M1, this M1 mass element, it is under the influence of the displacement x1 only, and we have this force which will be connected between the rigid support. This is the rigid support, and we have represented it here in the nodal diagram as the reference line. So F and M1 will be connected between the rigid support and the node x1. So we will have F, and here we will have M1. Okay, now between the nodes x2 and x1 we have k1 b1, so their parallel combination will be between these two nodes. So we will have here the parallel combination of the damper and the spring. This is b1 and this is k1. Now this m2, it will be influenced by the displacement x2 only, because mass are not influenced by the difference of the displacements. So and b2 and k2, they are also under the influence of the displacement x2. So here we will draw b2, this is m2, k2 and b2. So this completes the nodal diagram of the system. Now through this nodal diagram we will write the nodal equations for both the nodes x1 and x2. So at the node x1 we have the force F, and this force F will be equals to the mass m1 d2x1 by dt square plus K1 will be influenced by the difference x1 minus x2. So we will have K1 x1 minus x2 plus B1, and this is also influenced by the difference x1 minus x2. So we will have dx1 by dt minus dx2 by dt. Okay. So this is the nodal equation for this node x1. Now for node x2, at x2 we will have this b1 and k1 also, and b2, k2, m2 also. So we will write m2 d2x2 by dt square plus b2 dx2 by dt plus k2 x2 plus b1. b1 will be influenced by the difference x2 minus x1. So we will have here the difference as dx2 by dt minus dx1 by dt. Then we have this k1. So k1 we have x2 minus x1. So these are the two equations. This is the first equation and this is a second. So these two equations, they represent the mathematical model of the system. So we have drawn the nodal diagram, we have written the nodal equations. Now we have to find out the analogous system. Okay, analogous electrical system. So can write there are two analogies to derive the analogous system. First we have force voltage analogy and second we have force current analogy. So first we will draw the analogous system using the force voltage analogy. This is force voltage analogy. So according to this analogy, we have to replace the mass M1 by L1, that is mass is equivalent to the inductance. M2 will be replaced by L2. K1 will be replaced by the reciprocal of the capacitance. And force, it will be replaced by the voltage E. x1 charge, x1 is the displacement, so it will be replaced by the charge, and charge is what? q1. Similarly, x2 displacement, x2 is the displacement, so it is also replaced by the charge q2. Okay, and the damper, it is replaced by the resistance. So B1 is replaced by R1 and B2 is replaced by R2. So we have to replace these M1, K1, these variables by their respective variables in this equation. So first, writing the equation for the node x1, we have to replace F by the voltage. So we will have E here. Okay, this is the equation for node x1. So F is replaced by E, M1 we have to replace by L1, x1 with the charge q1. So we will have L1 d2 x1 ki jagah, in place of x1 we will write q1. So we will have d2 q1 by dt square plus we have k1. So K is replaced by the reciprocal of the capacitance. So we will have 1 upon C1. X1 will be replaced by Q1 and X2 will be replaced by Q2. Now we have B1 here, B1. So B1 is replaced by R1. Then we have dQ1 by dt minus dQ2 by dt. Okay. So this is the equation in the force voltage analogy. Now we know that I is equals to dq by dt. So if we replace this dq by dt's with I, then we will have E equals to, we have L1, then we have di1 by dt because here we are having q1, so it will be q will be equals to integration of I dt. So it will be I1 minus I2 dt integration, and plus we have R1, dq1 by dt will be I1 and dq2 by dt will be I2. So we have changed this dq by dt with I. So we have got the equation in terms of the voltage and the current. So this is the final equation for the force voltage analogy at node x1. Okay, this is for node x1. Now we will write the equation for the node x2. So for x2 node, we were having the equation as this. Okay. Again, we will replace the variables. M2 will be replaced by L2. So we will have L2 D2 Q2 by dt square plus B2 will be replaced by the resistance. So it will be R2 dq2 by dt plus we have K2 X2. So K will be replaced by the reciprocal of the capacitance and X2 will be replaced by the charge. So we will have 1 by C2 and we have Q2 here. Okay. Plus B1, it will be replaced by R1. So we have R1 D X2 and X1, they are replaced by the charges. Then we have K1. So K1 will be replaced by the reciprocal of capacitance Q2 minus Q1. Okay, and this is equals to 0. Okay. Now we have converted this equation in the force voltage analogy, and then again we will write I equals to dq by dt. So here we will have L2 di2 by dt plus R2 Okay, so we have replaced all the variables with their respective analog. So this is our equation number 2. We have obtained both the equations for node x1 and node x2 in the force voltage analogy. So this is the conversion or the analogous system of that mechanical system in force voltage analogy. Now we will find out the analogous system using the force current analogy. First of all, before starting with it, we have obtained these two equations earlier for those force voltage analogy. So we have to draw the analogous system also. It was in our question that we have to draw the analogous system. So using these two equations, we will draw the analogous system, and it will be, if you analyze these two equations, we have L1 associated with only the current I1 and L2 associated with only the current I2. There are the elements R1 which is associated with both the currents in both the equations, and also this capacitor C1 is also associated with both the currents. So this R1 and C1, they will be connected in between the two nodes X1 and X2. So L1, first we will draw L1, then we will draw a parallel line here, and in this parallel line we will have this resistance and the capacitance. This is our voltage E. This is L1, this is R1, and this is C1. Now L2, and we have R2, we have C2 also. So we have here, we have L2, this is R2, and this is C2. You have to just analyze these two equations. When you analyze, just see that which of the elements they are associated with both the currents. So those elements, they will be connected in the common side. Okay, they will be common to both the loops. So we will have here R2, this is C2, this is the current I1 in this loop, and this loop will have the current I2 in it. So R1, if you write the equation for R1, it will be I1 minus I2, or it will be R1 I2 minus I1. We are getting it in the equations. So this is the analogous circuit using force voltage analogy. Now we will derive the analogous system using force current analogy. Okay. So what were the equations? Again, we have this part. We have the equations for the node X1 and X2. So again, converting, for here we will convert this F force, we will replace this with current. Earlier we have replaced it with voltage, but here we will replace it with current. So mass M1 and M2, they will be replaced by C1 and C2, the capacitances. Then we have B1 and B2, the dampers. They will be replaced by the reciprocal of the resistances. Then we have K1 and K2. They will be replaced by the reciprocal of inductance. We have the displacements X1 and X2. They will be replaced by the fluxes Phi1 and Phi2. So these are the displacements which we have to do. And first let's analyze this equation for the node X1. We will have at node X1 we were having the equation as this. So instead of force we will write current. So here we will be having I. So force will be replaced with current, and then we have mass, it will be replaced with the capacitance. So we will have C1 D2. X1 will be replaced with Phi1, so we have Phi1 D2 Phi1 by dt square, plus K1 will be replaced with 1 by L1, so 1 by L1 we have X1 minus X2, so we will have Phi1 minus Phi2 Then we have B1. B1 will be replaced by 1 by R1. Then we have dx1 by dt. Okay, x1 is phi1, so we have d phi1 by dt minus d phi2 by dt. Okay, so we have obtained the nodal equation for x1 in accordance to the force current analogy. Now if we write this voltage equals to d phi by dt, then how we can write it here? We have I equals to C1 dE by dt E1 plus we have this 1 by L1, we have integration of E1 minus E2, this is dt, plus 1 upon R1 E1 minus E2. Or we can either use this equation also, this is the current equation, so we can use these equations. Now we will write the nodal equation for the second node, that is x2. So at node x2 we have, what was the equation for that? At x2 we were having this m2 d2 x2 by dt square plus this was the equation. So m2 will be replaced by c2, sorry, we have phi here. Okay, so phi will be there, d2 phi2 by dt square plus b2 will be replaced by 1 upon r2 K2 will be replaced by 1 upon L2. Then we have B1, so B1 will be replaced by 1 upon R1. Plus K1 will be again replaced by 1 by L1. Then we have D phi, we have phi 2 minus phi 1, and this is equals to 0. So we have written the equations for both the nodes at node x1 and at node x2. If we analyze these two equations, then we will get that we can interpret that C1 and C2, they are associated with the first and the second loop only. We have difference in the case of these resistance and the inductance. Okay, so what we can do, we have to draw the analogous system using this force current analogy. So we will have this current, then C1 is equals to C1 d2 phi 1 by dt square. So C1 is associated with only this I1, so it will be connected here. This is I, and here we are having this phi 1. Okay, now we have phi 2. So phi 2 will be associated with L1 also, R1 also. Okay, here also R1 and L1. Okay, so L1, R1, they will be connected between the phi 1 and the phi 2. So we will have a parallel combination here. This is phi 2. Okay, and for phi 2 we have this C2, it is associated with phi 2 only, so we have this capacitance, and R2 is also associated with phi 2, L2 is also associated with phi 2. So all these three, they will be in parallel combination and associated with this phi 2 only. This is C2, this is R2, and this is L2, R1, L1. Okay, so this is the analogous circuit for the system using the force current analogy. So in this way we can solve any problem in which we have to determine the analogous systems using these two analogies. First we will convert the system into its nodal diagram, and through this nodal diagram we will write the nodal equations, and after that we will convert the nodal equations according to the force voltage and force current analogy to obtain these two analogous systems. So I hope this problem is clear to you. You have clearly understood this problem. Thank you.